If you got stuck on this limit with L'Hopital's rule, or maybe you missed this on your last exam, you're going to understand why in just a few minutes, but only if you stick around. For this limit problem, the first thing I want you to look at is, okay, what's happening with the numerator as x approaches infinity? A lot of you get this wrong, but when you see a trig function like this, it always helps to step back and to think of its range. Remember, for sine of x, the range goes from -1 to 1. And so because that range is fixed, you can almost treat it like a constant as x approaches infinity, right? And if you remember, when you have x minus something that is fixed, when x is large enough, that something, that constant, or in this case sine of x, is essentially insignificant and goes away. What this means is that with the original limit then, x minus sine of x also approaches infinity. And so with the limit as x approaches infinity of x minus sine of x over x, this leads us to see that this limit approaches infinity over infinity. And if you saw this and started using L'Hopital's rule, you are on the right track because that's the way to go, because infinity over infinity is one of the indeterminate forms where we're allowed to use the rule. And in case you don't remember L'Hopital's rule, that's okay. But as a refresher, you take the derivative of the numerator and then the derivative of the denominator, and that gives you a whole new limit that usually is simpler to work with, but in this case, it has a really interesting twist. So when I take the derivative of the numerator, I get 1 minus cosine of x, and then for the denominator, you just get 1. And by inspection, it looks simpler, right? Because we got rid of a variable on the denominator. And then when you look at this by inspection, many of you may have already just claimed, hey, you know what? The answer is the limit doesn't exist. It doesn't converge. But is that correct? So you tell me in the comments below. Again, what I want to do here is I see another trig function, cosine of x in this case, and my approach for solving this is no different. I want to look at the range now of cosine of x, and again, it's going to be this fixed bounded interval between -1 and 1. But now when you try and simplify the limit, it's a little different here because check this out. We can essentially squeeze the limit. And what do I mean by that? I'm going to take the ends of this interval, this -1 and 1, and instead of sine of x or cosine of x in this case for the numerator, I'm going to plug in each value and do 1 minus that to see what we get. So 1 minus the lower end of the interval, -1, will give me a 2. And then 1 minus the upper part, that 1, will give me a 0. And what does this mean? Okay, this is going to give you the range of the numerator of this limit right here. So I can actually rewrite this limit now as being sandwiched or squeezed between two values. I'll take the smaller numerator value, that 0, and I'll put it on the left here, divided by that denominator of 1. And I'll say that that is going to be less than or equal to the limit. But then the upper bound that's greater than or equal to the limit itself is going to be that larger numerator of 2 divided by 1. And so when you look at this, it looks like the answer to our problem is that the limit doesn't exist, right? Because if you simplify this, this is basically telling you the limit is just in this range of 0 to 2. But believe it or not, the answer actually is not what you think. And to figure out why, I'm going to get into that in just a sec. But before I do you want to support me by bringing you more math tricks? Then ninja kick that subscribe button and pick up a shirt or mug in the description below so you can rock that ninja look. And only for you serious students, if you want to get the most out of my dojo, becoming a member will get you early video access and more goodies as well. So I'm going to restart this problem now, and we know now L'Hopital's rule is not going to help us. If we applied it a second time above, you would have still been stuck. What I want to do now is look at the original limit and say, you know what? Just blind memorization of L'Hopital's rule and using it just because you can isn't always the right answer. Look at this. We can split this fraction up into two parts, right? I can rewrite this limit as simply x over x, which is 1, minus sine of x over x. Now, this becomes a difference of two limits. We can write this as two separate limits, right? And we know that the limit of a constant as x approaches infinity on the left here is just a constant. And this limit on the right, it's a little bit different from my other video for squeeze limit where the x approaches 0. Here it's approaching infinity, but I'm going to leave it as an exercise to you guys in the comments below to tell me what the answer is going to be for this limit. And as a hint, think about the denominator growing without bound and having a fixed range for